Good morning, student. Today we will discuss nuclei and we will discuss about the nuclear force and how the nuclear particle behave that we are going to discuss. In atom chapter, we have studied about the atom. What is the atom? And also we have discussed about the radius of the atom and energy of the atom. Energy minus 13.6 upon n square. But that was atom. Now if this is atom, the very big size of atom, and the size of the atom is 10 to the power minus 10 meter. Here we have one nucleus, positive nucleus, and that positive nucleus is confined. Nucleus is confined in very small distance, that is 10 to the power minus 15 meter. Very small distance, 10 to the power minus 15 meter, and that will be equal to 1 Fermi. This is about the Fermi, and it was given by Enrico Fermi. In the honor of Enrico Fermi, we have the radius of the nucleus. So when we say that this is the nucleus, and we know the nuclear particles, there are number of nuclear particles are there. Today we know about the neutron and proton, or the nucleon. So we are going to discuss how this nucleons and who holds these nuclear particles together, and then later part of the chapter we will continue with the nuclear fission and fusion. So question is, what when we have the nucleus, in nucleus, how you will measure the mass of a small particles? Like generally we measure the mass in kilogram, 1 kilogram, 2 kilogram, but in atomic physics we will use the AMU unit, that is called the atomic mass unit. And one atomic mass unit, it is equal to the mass of one C12 atom, isotope of carbon, C12 atom upon 1 by 12. Now what is the mass of carbon atom? The mass of carbon atom is 1.992642 into 10 to the power minus 27 kg. This is the mass of carbon atom divided by 12. So one atomic unit will be 1.660539 into 10 to the power minus 27 kg, and that will be the mass of the one atomic mass unit. In that atomic mass unit, if you calculate the mass of proton, the mass of proton will be almost same, and it will be 1.67 10 to the power minus 27 kg. 27 kg we all know, but in atomic mass unit it will be 1.00127. That will be the mass of proton, 783. You can say 783 unit. And mass of electron in that unit system. Which unit system? AMU unit system. Electron will be 0.00055 unit. So we cannot use here the kilogram. We will use AMU, and in short AMU is written as U. It is you means you can represent with U also. So the theory was going on कि nucleus is there and the nuclear particles are there, and it was not knowing at that time. देखो what happened in 1911 atomic structure came. 1911 the Bohr's and Rutherford theory, and 1896 it was J.J. Thomson. J.J. Thomson who has given the theory of electron, and then here we can say that proton or nucleus, not proton, nucleus. And then the whole theory was not known. People were talking that only atom we have atom and nucleus, and in nucleus some positive things. In 1932 it was James Chadwick, and he has given one theory. And what is the theory? That existence of the neutron particle. James Chadwick, he has given the theory of existence of neutron, and what he did, he took one alpha particles. What he did, alpha particle, or you can say that 2He4. So when alpha particle is bombarded with beryllium nucleus, when it is bombarded with the beryllium nucleus, what will happen there? This beryllium nucleus will split into two small particles, any two small particle A plus B, and then we can apply the law of conservation of energy. Energy conservation also we can apply here, energy conservation and momentum conservation. So if we find the momentum of left hand side and right hand side, and energy of left hand side and right hand side, this equation will be balanced only when we say that it is the radiation which will come out from the nucleus, that will be because alpha particle is bombarded, so some radiations came out. That radiations were neutral in the characteristics, and from there they concluded that apart from the alpha particle or proton or positive thing, something else inside the nucleus, and that something else is nothing but it was neutron, and they concluded that neutron is found inside the nucleus. The free neutron is unstable. Free neutron is unstable. Free neutron is unstable, whereas the free neutron is unstable. Neutron is unstable, whereas their bound neutron, actually it is neutron, is stable, and most of the nuclei are the neutrons are bound. Then we have three basic definition. One is isotope. Isotope means the same atomic number. Atomic number is same, but mass number is different. And it was 1H1, 1H2, 1H3, and this is called hydrogen, this is deuterium, and this is tritium. Later on many isotopes came in. Then we have one more definition, that is isobar. What is isobars? Isobar, same mass number and different atomic number. So here the example for that 1H3 and 2He3. Then we have isotones. Isotones means which have the same number of neutron, same number of neutron. It is called isotone. Then later on, we we have seen key Rutherford and then Geiger and Mardison. Actually, it is Geiger and Mardison, and they found the size of the nucleus. So, how they find the size of the nucleus? For that, we have one simple experiment: distance of closest approach. Distance of closest approach. See, when alpha particles of 5.5 million electron volt energy, that is their kinetic energy, they enters here and they strikes with the nucleus. तो ये भी अल्फा पार्टिकल पॉजिटिव है और ये भी पॉजिटिव है, तो कितनी डिस्टेंस तक अल्फा पार्टिकल जाएंगे? द अल्फा पार्टिकल विल रीच अप टू दिस डिस्टेंस. इससे आगे अल्फा पार्टिकल नहीं पहुंच सकते, वो यहाँ तक आएंगे. न्यूक्लियस का ये चार्ज, ये डिस्टेंस कहलाती है, दिस इज डिस्टेंस ऑफ क्लोजेस्ट अप्रोच. एंड दिस डिस्टेंस ऑफ क्लोजेस्ट अप्रोच d is found near about 4 into 10 to the power 14 meter. So with this experiment, alpha particles experiment, it was concluded that it is very short range. Nuclear force के बारे में उनको मालूम चला, and that nuclear force is very short range. Rutherford's calculations are based on purely Coulomb's repulsion, and that Coulomb repulsion because of the positive nature of the alpha particle. And from the that experiment or distance of closest experiment, we found the size of the nucleus, and it was found that the radius of the atom r equal to r0 a to the power 1 by 3, where r0 is 1.2 10 to the power minus 15 meter. From this we can conclude the size of the nucleus, and then later we can calculate the density of the nucleus also. Then volume of the nucleus. Volume of the nucleus. What will be the volume of the nucleus? The volume of nucleus will be V equal to 4 by 3 pi r cube, and we can put this r here, so it will be 4 by 3 pi r0 a to the power 1 by 3 and then cube. So when we solve this, it will become 4 by 3 pi r0 cube a. This is the volume of the nucleus. Later on, if we know the volume, we can calculate the density. Density, how will calculate the density? The density of the nucleus will be density of nucleus, it is equal to mass of the nucleus upon mass of nucleus upon volume of the nucleus. Volume of the nucleus. Now what is the mass of nucleus? Suppose A is mass number. If A is mass number, so mass of nucleon will be Ma upon 4 by 3 pi r0 cube into A. This A cut, it will be m, 3m actually, this 3 will go 4 pi r0 cube, and we can put the value here, 3 into mass 1.67 10 to the power minus 27, and when we calculate this 3.14 r0 1.2 10 to the power minus 15, the whole cube. So when we put it this, it will go that side, and it will be approximately how much it will come. When we solve this, it will come, see, if you 27 and this will be 45, so 45 will go in the numerator, so 45 minus 27, so it will near about 18. So the size of the density of the nucleus is 2.3 into 10 to the power 17, 2.7 into 10 to the power 17 kg per meter cube. And this density is very close to the density of the black hole. Black hole के पहले जो आता है neutron star, this is very high density. And you know, neutron star also have the density 2.3 10 to the power 17 kg per meter cube. Then what is the density of the water? The density of water is 10 to the power 3 kg per meter cube. So we can compare, this is 10 to the power 3 kg, and what about the density of the nucleus? It is near about 10 to the power 17 kg. So this number is very big. Okay, so that is strong density. What it will do, we will see in our next class what it will do. ठीक है ना? Yes, thank you.